Hi there. Welcome to the sixth problem of the Problem Corner playlist of the Genesis YouTube channel. Today, we will see a simple question where a ball is colliding with the walls and the roof of a cabin. So without further ado, let us see the question. The figure is shown. A small ball is projected from the floor of a cabin of height h with a speed u at an angle theta from the floor of the cabin. It collides with the front wall, then with the roof, and then falls directly to the floor. Assume all collisions to be perfectly elastic and neglect friction at all contacts. Find the time taken by the ball to reach the floor after the collision with the ceiling of the cabin. The data given to us is h is 7 meters, u is 20 meter per second at an angle of 37 degrees, and g we have to approximate as 10 meter per second square. I suggest that you pause the video and give it a try. The question looks a bit difficult, but it is not. Now we proceed with the solution. In general, what I have observed is that students face difficulty in solving such problems, as they immediately start writing equations for each collision and then do a lot of calculation. It will get you the answers, but let us hold our horses and see what we can infer simply from the situation. Now, this figure shows how the ball moves, first colliding with the wall, then with the roof. First, we resolve the initial velocity into x and y components as ux as 16 meter per second and uy is equal to 12 meter per second. I trust you can do that. In this question, we will need one simple result from collision, that when a small ball makes an elastic collision with a frictionless large wall, its velocity parallel to the wall remains the same and perpendicular to the wall flips. With this in mind, the easiest way to solve this question is to focus completely on the vertical or the y motion of the ball. That is shown here. Let us try to understand what it represents. As the ball starts to move, the y projection of the ball starts to move with velocity uy. The ball goes and strikes the wall and its x velocity flips, but y velocity remains constant. So the y projection is unaffected and it keeps moving upward. But what happens when the ball strikes a roof? The y velocity flips now and the x remains the same. Now look at the y projection. Here I have drawn with dotted lines the path which the y projection would have taken if the collision with the roof didn't happen. Now when the ball collides with the roof, the y projection instantaneously comes from the point B to the point C with the same speed downwards. Why does this happen? Because the y component of velocity on the roof got flipped. The dotted part in the y projection is cut off. Now, in the time the ball reaches from the roof to the floor, the y projection reaches from the point C to D. Now, this means that what we essentially have to find is the time taken for the y projection to move from C to D. So, instead of analyzing this two-dimensional motion, we are now reduced to analyzing one simple one-dimensional motion in which we have to find the time from C to D. Now, how do we find this time? Remember that this y projection is part of the full path without the roof collision, and therefore this whole path is basically a ball thrown upward. And the moment we realize that, we can say that time taken from A to B should be equal to time taken from C to D. And this finishes off the question. You're done. Why, you say? Now time taken from A to B is very easy to find. In the time TAB, the y projection reaches the height h is equal to 7 meters under uniform gravity. So TAB can be found using 7 is equal to 12t minus half into 10 into t square. This is s is equal to ut plus half at square applied in the y direction. Taking upwards positive, y displacement is plus 7, initial y velocity we found to be plus 12, and acceleration is minus 10. Simplify this, you will get a quadratic equation 5t square minus 12t plus 7, and solving this, which I leave up to you, we get two values of time, 1 and 1.4. Why are we getting two values of time? Because understand, we found the time at which the displacement is plus 7. There are two such instants, when the ball moves from A to B and when the ball moves from A to C. In both cases, the displacement is plus 7. And it is obvious that the greater root 1.4 corresponds to the path A to C. Therefore, we'll reject that. We want the time from the path A to B. So time from A to B is therefore 1 second, and that is our answer. You realize how small the actual solution is? Majority of the work was mental work with one single quadratic equation to be correctly written, and there you have the answer. But that comes with a crystal clear analysis of what is actually happening in the situation. In many complex questions, we must seek out that one or two simple things that are going on, and often we are rewarded with the right answer. I hope you liked this question. For more such interesting questions and even more interesting solutions, keep watching the Problem Corner playlist of the Genesis YouTube channel. Serious JEE aspirants can also check out the ongoing playlist of the solutions of the JEE Advanced 2020 examination. In addition, we have one more playlist called Essentials, in which we discuss essential questions necessary for all problem solvers in physics. And finally, if you like the work, like, subscribe, and share widely with your friends. Till the next video, stay safe and stay healthy, you all.